Hello, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. Now I would like to introduce today's presenters and go over today's agenda. With us today, we have Justin Fry. Justin is the Senior Product Line Manager of Medical at Smiths. Joining him today is Danielle Riveros. Danielle is the Principal Engineer of Medical at Smiths Interconnect. Now I'd like to go over today's agenda. We will cover the current and emerging trends in medical device industry overall. We're going to discover the current trends toward the more demanding applications requiring increased connector density and performance. We're going to find out more about the D04 connector, the latest addition to our popular D-series platform, and what it is and why it is unique, and understand what market segments and applications will benefit from this new product.
So what we'll be talking about today for the most part is a focus on electrophysiology and the imaging market trends. And for imaging, we're looking more at an MRI space, and that'll make more sense as we get into the new connector technology that we're going to be talking about later that we're introducing, because it applies pretty well to that segment. And then it'll also make a lot of sense why it applies to electrophysiology after we're done as well. Starting with electrophysiology, the way this slide is formatted is we'll talk about some technology trends, some global trends that drive that market, and then how that applies to a connector, or what types of considerations we take into account, but also that our customers and OEM manufacturers have to think about as they're designing their devices and how it impacts the interconnect elements of their products. So for an electrophysiology, it's a minimally invasive procedure. So anytime we talk minimally invasive, or we're talking about entering a patient's body through an orifice that isn't a natural orifice, we always the drive is continuously for safer, faster procedures, less patient in the bed time, less recovery time for patients. And it's all about making sure that the patient has the best possible experience to curb resilience or resistance to future treatment, but also to enforce this type of therapy as a viable alternative to other therapies that treat arrhythmatic conditions in the heart, such as pacemakers or being on medication for the rest of your life. So these minimally invasive procedures don't come without risk, but there's a constant drive to reduce that risk. Some new exciting technology that is pushing in that regard are things like single shot tissue ablation. And that is done via irreversible electroporation in the medical field, or in the electrophysiology field. It's more commonly known as pulse field ablation, which is probably something some of you have heard of. And that is, it seems like it's coming pretty quick. There are some devices that are in process of being approved for use. We're also seeing, along that same vein of that single shot ablation, we're seeing rapid advancement in cardiac mapping. From 3D mapping, which has been around for a while, to the latest mapping technologies in high density mapping. These mapping catheters are intended to provide the most clear and diagnosable map of the heart's electrical signals. Again, the whole idea there is you're spending less time in the patient's body, less time under fluoroscopy, shorter recovery times, faster turnaround times for patients, but without sacrificing your ability to diagnose those conditions in the heart that need to be treated. And then we're also seeing increased use of intracardiac echocardiography, lovingly known as ICE. ICE imaging has been around for a while as well, but it is due to the advancements in ICE imaging technology and the advent of even 3 and 4D ICE capabilities. You can start to really shorten the length of procedures, because that ICE catheter gives you real-time imaging inside the body for really accurate placement of especially a mapping catheter. It also helps assist in fluoroless procedures, which means less X-ray radiation in the EP lab and on the patient. For global trends, we are seeing an increased aging of populations globally. People are living longer, healthier lives. Well, healthier is up for debate, but we'll say longer lives. But there are rising incidents of cardiovascular disorders that come with both aging populations and just lifestyle, and even in some cases genetics. So things like AFib and VFib, more specifically ventricular tachycardia, are among the fastest growing arrhythmatic conditions worldwide, and that's driving strong growth in the electrophysiology market. Growth is further supported by a increasing acceptance of mapping and ablation products worldwide, as well as adoption of EP catheter labs, so satellite labs that don't have to be within a hospital, but they're specifically EP labs. Those are starting to become more and more popular as electrophysiology becomes a more normal form of care. We are also seeing a sharp increase in industrialized countries that's driven by really, really strong investment in clinical research and a high acceptance rate for new devices. And in the way of clinical research, it doesn't take much searching on your search engine of choice to just see the droves of clinical research that is being done. The support from the medical community and the medical OEM community is very high for this technology because of the promise it shows in helping people have better lives. All that said, there are some drawbacks to electrophysiology beyond just the patient outcomes. It is considered high cost in a lot of cases, and a lot of that's just because it's still relatively new in terms of reimbursements. And when we talk about reimbursements, we talk about how much of your procedure your insurance will pay for versus how much you have to pay out of pocket. It's an ever-changing landscape because of the evolution of the technology, the types of conditions it treats, and it's just an ever-changing landscape. So we do expect that over time, as that matures, that will be less of an issue, but there still is some gaps in the way of reimbursement. What this all means for the connectors. Well, first and foremost, these are high volume procedures. When you think about the part of the device that's entering the patient or that's in the sterile field in the lab, those are either single use or limited use products, meaning they're either discarded after each patient or maybe after between 10 and 20 patients. So with the amount of procedures being done and the fact that they're all limited use, these connectors and interconnects all need to be relatively cost effective to warrant them as a suitable replacement for, like I mentioned, prescription drugs or a pacemaker. We're also trying to combat, there's a lot of new entrants in the market, not just on the OEM side, but also even in our part of the device. There's a lot of connector companies trying to innovate and create more value to try and capture a lot of this market because it is such a fast growing market and it's such an interesting field. We are also seeing a drive toward increased use of hybrid connectors. And we say hybrid, I know some of you might think hybrid means we're doing maybe electricity and fluid or electricity and gas. And that is one version of hybrid. In this case, we're talking specifically about hybrid connectors that are able to have a portion of the connector allocated for high voltage power signal, and that's typically for ablation, combined with low voltage signal lines. And we have to think about the orientation, shielding, what type of dielectric is needed between those contacts, how they're oriented to make sure that every part of that, every connection in that interconnect works as planned. We're also seeing density reach new heights. This is driven by some of the aforementioned device innovations in the way, especially in the way of mapping, where we're trying to create high density mapping, which is driving up the density of the connectors, keeping in mind that these connectors still have to be mated by one hand. Typically, an electrophysiologist is using one hand to mate, demate, while they're using the other hand to say stabilize the single end use of the device. And they also have to be very easy to mate and demate. They can't be, when you're inside of a patient, you can't have something that's hard to mate and demate if you need to have any type of mate or demate action there. So we have to consider, when we're designing a connector, what is that perfect balance of how many contacts can we accommodate versus the functionality the customer is looking for, and can we do all of that while keeping it in a package that an end user electrophysiologist can use every day, multiple times a day. Shifting over to MRI, you'll see some overlap, especially in global trends, but again, it'll all come together soon why we're talking about both of these technologies that are seemingly different. In MRI, there's a continuous drive for improved patient access. meaning MRI systems that can accommodate large patients, claustrophobic patients, all shapes, sizes, and persuasions of patients need to have access to this type of imaging, because it is a premium imaging that can be used to diagnose things that many other imaging systems that are non-invasive cannot. So there's a drive toward open bore systems, portable systems, making sure we can get MRI to patients when and where they need it and that they have access to the system. We're also seeing power increasing, I call it power, but it's really the power of the magnets up to 4T and greater. T being a Tesla, which is a measurement of the power of the magnets being used inside that MRI. And the benefit of higher power is you can capture a much more, let's say, defined image much more rapidly versus a lower power machine. However, a higher power machine's drawback is that it also picks up artifacts more rapidly as well, because it's just operating at a higher power. There are some things that are being done to correct that, and which I'll talk about. We're also seeing a growth in high V MRI, which is actually a very low power MRI that's used in very certain cases, but it has, due to the low power, it picks up nearly no artifacts. And again, depending on what's being imaged, it can be used to capture images just as quickly as a higher power system, and they're not quite as expensive. To combat some of the artifacts and workflow issues for MRI technicians, we're seeing adoption of AI and deep learning. And this is basically intended to automate repetitive steps. They load these AIs with lots of images, pre-existing images, to train the AI to identify and remove artifacts already. And again, the whole idea here is, we know MRIs are expensive. It's a durable piece of equipment, and the whole value proposition there is based on, can we get patients in and out? Just like most medical procedures, we don't want to keep patients in the bed longer than they need to be, and they don't want to be in the bed longer than they need to be. So everything is driven toward making both the patient and the MRI technician's job satisfaction better. We're also seeing increased advent of MRI-safe implants and pacemakers, which further increases access to MRI for a broader population of people. And finally, a more recent trend is in the way of helium-free. So helium is the coolant that's used to keep the magnets at a reasonable temperature while being used. Some of the newest innovations in the market are, they're, quote helium-free. They're not actually helium-free. They just use a fraction of the helium required by a traditional system. And the idea there is it's a lower cost of ownership, lower maintenance costs, potentially longer lifespan of the equipment, but also a more sustainable product that relies on less critical resources. From a global trend perspective, MRI is considered very expensive in terms of a procedure, but also in terms of the equipment itself. So MRI installations are driven by expansion of both manufacturing and access in Asia Pacific and Latin American countries, including increasing healthcare tourism. Healthcare tourism being somebody in one country going to another country specifically for the sake of access to systems that country has. And it even happens in the US from state to state as well. Increasing access to healthcare and improved infrastructure and public-private partnerships are also driving adoption of MRI, again, especially in those Asia Pacific and Latin American countries, where the hospital itself may not have enough funds to install an MRI. Those public-private partnerships are helping close the gap. And then the increasing prevalence of chronic illness will continue to drive MRI demand moving forward. As an imaging modality, I already mentioned this, but MRI is considered a premium form of imaging. It is able to capture types of images that are very challenging to get with any other type of imaging technology, especially in the way of soft tissue diagnosis for things like tumor or cancerous tissues, as well as soft tissue trauma, such as brain and spine injuries. It's still one of the leading, if not the leading, imaging modality for diagnosis. And then finally, another global trend is the diversity of MRI technicians. So the end user who's actually operating the device, the demographics are ever changing. the balance between male and female, the ethnical background are all ever changing, but they're becoming more diverse. What does that mean for the connector? Well, because it's such a high cost system and all of the OEMs in the market are competing to have the best possible product at a price that's the most accessible, there's always pressure for cost reductions, even when we think of interconnects, which you think the interconnect is not the most expensive part of an MRI, and that is true by a wide margin. However, when you've already done as much as you can to reduce cost elsewhere, being a mature technology, the connector is now definitely considered within the realm of things where cost needs to be controlled as much as we can. The whole drive there is to, again, reduce total cost of ownership, but also reduce the cost per therapy, which is a measure we use to really determine the value being gained by the product. We're seeing increased electromagnetic noise as a result of those higher power systems. Those just have to be managed and considered because it does take into account what type of shielding, spacing, the materials we use in the connectors to make sure that, one, they have to be magnetic free, but also they have to be able to protect against outside noise or noise between contacts. We're looking at higher durability requirements. If you've ever seen an MRI, if you've had an MRI, or if you're familiar with the process, these technicians, a lot of it's muscle memory. So a lot of times they don't even look at where the connector connects. They just know where it is, and they just try to connect the connector without even looking at it. So a lot of these MRI machines have guides, like guides that are built into the machines that help drive the connector into its mating part of the bed. But we have to take into consideration that depending on how aggressive they are with those connectors, can they bend or damage any part of the connector while they're not quite looking where they're connecting it. They're just relying on those guides. And that's definitely a consideration we have to take into account early to make sure that the structures protecting those contacts can stand up to that type of usage. And then increased ergonomics, driven by more patients and changing demographics. So the fact that MRI technicians come in all shapes and sizes, patients come in all shapes and sizes, and no matter that combination, you want it to be comfortable, a comfortable environment, a comfortable procedure, a repeatable procedure for everyone involved. So to wrap up the market trends, a lot of what we're seeing in the market, especially in the way of electrophysiology, is high density, meaning we need to fit more into the same size package without sacrificing the weight too much, without sacrificing the mate ability, meaning the mate forces too much. And the whole goal there is to get the best possible image as fast as possible, which means we also have to have them fit for use. For MRI, I talked about them needing to be quite rugged because they have to last for a long time. MRIs are durable equipment. There's no real disposables. So everything on that equipment has to be durable. Whereas in electrophysiology, you still need the same type of performance, but for a shorter period of time, right? Because they're either limited use or single use, but you still need a very reliable connection, and it has to last throughout that procedure. Reliability and integrity, anything that has to do with imaging, any imaging modality in medical, and you could argue even outside of medical, but let's say in medical, any imaging modality, image resolution is king. Whether it's ultrasound, whether it's MRI, whether it's an EP map, we, as an interconnect company, we help make sure that image resolution, those signals being delivered, are as good as they can be, as frequently as possible, and that it's a very reliable system. We do not want the interconnect to be the reason anything on that system doesn't work during a procedure. And then customization. All of our customers are able to typically start with one of our, let's say, platform style connectors for their initial testing, but without fail, they eventually want to customize away from it. And that's just because they're pursuing the technology, or they're pursuing the therapy in a way that's just slightly different or slightly variant from some of their competitors. And it's all about trying to gain a competitive edge. So we offer full customization of our installators, meaning you can take the shell of that connector and we can change anything you want on the inside of it to meet your signal power requirements, your shielding requirements, obviously within the realm of what's possible with physics. But nearly all of our customers eventually go to the route of customization. So now we will transition to our high density connectivity solutions, which will include a conversation about the new product line extension we're going to be talking about a little later. So our new connector is called the DO4. And as I mentioned in the prior slides, what we're seeing in the medical market is a trend toward higher contact density while maintaining proper ergonomics for the end user. We're seeing portable devices, wearable devices, single-use devices, minimally invasive, I mean, you name it, right? The need is constantly driving toward more technology fit in the same package, or more capability fit in the same package. And we are able to assist our customers in that way, and OEM manufacturers in that way, by designing these new connectors that are really come from feedback that we get from the market on whether it's a custom design that we're working on or just general feedback we're getting about where the markets are heading. A lot of our intent of this design is driven, again, or is a result of direct feedback we get. So this connector is, we see it really pushing toward electrophysiology in the way of mapping, ablation, and I would say specifically, pulse field ablation, the new ablation technology that's upcoming. It's a few devices in the market that are, let's say, getting close, or they have a roadmap toward approval to be used here in the United States. We're starting to really see those high density needs increase in electrophysiology. In intracardiac imaging, we think about intravascular ultrasound, which isn't necessarily intracardiac, but we consider it adjacent because it is still an ultrasound or echocardiography procedure that requires high density signal to be delivered via an ultrasound transducer. So we sort of group IVUS and ICE in the same sort of conversation there. And then general imaging, MRI, and even endoscopy. One of the benefits of this new connector technology is it does provide us with one of our largest footprints. And it's not a large footprint. We'll go over the size of it later. It's not a terribly large footprint, still one hand operatable, but it gives us a good amount of footprint to even fit fiber optics, for instance, through the connector. In terms of the standards that we expect from this DO4 connector, and on the left there you see a picture, our DO1 is on the left, in the middle that is our DO2 connector, and then you see the new DO4 connector. It comes with 82 position standard, and that is a standard that's based, again, on a lot of the market feedback we've received on sort of that baseline level of where we need to be. We will share some examples of how we can achieve a higher density or using alternate technologies. Maybe the density is lower, but the market that it's for, it's the perfect connector for that market, and we'll talk about that later. We design all of our connectors to be touch-proof, IEC 60601 compliant, just because we know that they are in the path of electricity. We just want to make sure that everything we're producing is safe. The D-shape layout provides an innate keying feature. You can only mate this connector in one way, and that flat edge always lets you know where, let's just say for the sake of this conversation, that's the top of the connector. So you can always align it because you have that flat edge to be an indicator. There's also a push button on the top for your thumb, which is also another very easy way to know where, let's say, the top of the connector is. So it's very easy to mate and demate, and you can't mate it incorrectly, at least not with the amount of force a human could apply. It's rigorously tested. We do post a lot of our test results on our website, on the product line pages. However, if there's something you're looking for, if you're designing a device and you have some information that you need that is not part of what we publish, we do additional testing. We can always look at what we did for qualification, but we can also talk about getting information needed if there's something that isn't there. We always design for ergonomics. Even with these high density connectors, you'll see when we talk a bit about more of the specifications, how even at this high density, the mating and unmating forces are, I would say, more than reasonable compared to other connectors of similar density in the market. And then the improved value for the end user. We try to keep these things pretty simple, easy to clean, because we know they go through cleaning or sterilization cycles. We want to make sure that there's no edges that would catch or cut a glove, of an operator. And then we also want to make sure that they meet the cycle life. So we say improve value for end user. We also talk about the value per therapy or the cost per therapy. So if you need a version that'll last 10,000 cycles, we got you covered. If you need a version that'll last much longer, we got you covered. If you need a version that lasts less, then that's obviously well within the realm of possibility given where we're at with the mating cycles.
Hi guys, here I'm going to get into the design details of the DO4. So as Justin mentioned previously, the DO4 comes from the D series family, the D01, D02. Those are being standard platform products that we offer. Now we're incorporating the DO4. Some of the design details that we have on the DO4 is that it allows for multiple contact technologies. We're going to get into here later on about the different contacts that we can implement. We got the spring probe, the standard pin and socket, and the hyperboloid contacts. We also offer autoclavable versions for the DO4. And another key detail is that it's easy to incorporate into the equipment panel and cable assembly. So very customizable opportunities for the DO4. Another key feature to get into is the ease of assembly and use. I know Justin touched base on this a little bit, but it's a quick connect, simple one-handed operation. I know that's been a desire, and with a lot of clients that we've discussed with is one-handed mating and unmating. So this DO4 allows that, the mating force, the location of the push button, and the type of connection that we have. As we mentioned, it's visually intuitive. So with one hand, you can kind of feel your way into the connection. You don't really have to pay close attention with your eyes to align keyways or things like that. So again, really easy to mate and unmate. Also, crimp and poke termination eliminates the need for pre-tin and solder, or it also eliminates the need for a shrink boot. So again, some of the enhanced functionalities that we have is the ability to implement different contact technologies, different amount of contacts. Our standard one is 82 contacts. We've gone up to 120, 130 plus contacts, depending on the type of contact. Obviously, we can also go lower if needed. The push button latch feature, again, is something that's been a key feature for this connector and received very, very well. The D-shaped, very intuitive to mate. Another main component to that is that it really eliminates the ability to bend pins. I know with a lot of connectors, you can bypass a keyway, insert improperly, and you bend the pins. And once you bend the pins, it's the connector's pretty much shot. Also, we offer custom cable assemblies, and the complete solution is essentially sourced by us. So it eliminates the need to go to different suppliers and get the different items needed to complete the connector. Here I'm showing an exploded view of our standard offering of the DO4. So again, the 82 pin contacts. So just stepping through each item, we have the plug body, the plug insulator, the 82 contacts. They're 0.4 millimeter in diameter. The Oderker clamp, the retainer, the cable / retainer, which is the strain relief boot, and then the cable. Those are all the components for the DO4, the standard DO4, and then we show the receptacle and the plug. Some of the features to highlight here is, again, this one is the 82 contact version. We can swap out insulators depending on what type of contact, how many contacts we need, depending on if you have a higher voltage requirement. All those items we can work with you to customize. The receptacle size is 33 millimeters long and about 46.5 millimeters in diameter. One thing to note there is that the 46.5 millimeters is the outer diameter of the panel mount. So really, when you get into the plug side, you have a 92 millimeter long plug and about 35 millimeter in diameter. So that's what would go on your hand, depending on, it can accommodate small hands or large hands. It wouldn't be an issue. Also, we do provide this as a complete assembly, but if the customizable solution requires for some assembly on your end, we also provide the necessary tooling for the proper insertion of the contacts. Some of the performance, mechanical and electrical performance that are here to highlight. The latch retention is 7 pounds. Contact insertion force is less than 6 pounds, and the contact retention is greater than 10 pounds. The crimp tensile, depending on the gauge of the wire, 28 requiring a little bit more, 1 pound force, and the 30 gauge is at 0.8 pounds of force. Aside from being autoclavable, it can be chem wipe, ETO. So these 3 sterilization options are available. We are at about 100,000 cycles for mating, and the temperature pretty standard, minus 40 C to 125 C. For electrical, we are insulation resistance of greater than 5,000 mega ohms at 500 volts. DC, our DWV, dielectric withstand voltage, is at 1,000 volts, and our LLCR, the contact resistance, is at 13 milliohms at 100 milliamps. One thing to note is that the DO4 meets all the electrical requirements, and it uses low resistance pin and socket technology, which it is an advantage over the spring probe counterparts. Some of the essentially comparisons with the competitors or similar connectors that are on the market. We've highlighted some of the features here. We are comparable in the density of the max number of contacts. Again, our standard is 82. We get up to 120. We have seen 78 and 128 contact configurations available. Mating cycles, we are at 100,000 cycles. What we've seen is 5,000 cycles typically out there. Our mating force is 8.5 pounds max versus 16.5. So again, this offers for easier ergonomics, use with one hand. Don't have to push in real hard to get it in place. Color coding, we're 1 less than what we've seen. We're at 6. We've seen 7. Autoclavable versions. I mean, if you're in medical, you really need to be able to be autoclaved, or you're going to be at a disadvantage there. So we've seen that available. And again, the intuitive mate demate, the D shape really allows for easy intuitive mating, and the push button latch is easy for one-handed operation, which is typically what we've seen is a twist to mate or twist to demate. So a little bit less intuitive there. Some of the contacts that we've already implemented into the DO4 are these 3 here: the spring probe, the hyperspring, and the hyperboloid. So depending on the need, depending on the amount of contacts needed, we'll work with you to select the appropriate one. Each one has certain benefits that are brought to the table. The spring probe, extremely high density, and also over 100,000 mating cycles. The hyperspring is also suitable for high density. It does provide kind of a cleaning, a wiping operation in between cycles. Depending on if it's on a harsh environment, that's a benefit. As you mate and unmate, kind of wipes it clean. And the hyperboloid contact is specifically designed for interconnects in imaging systems and coils. And the current rating for the hyperboloid is between 4 and 50 amps per contact. So how can Smith's interconnect help? one additional key benefit that we've touched on before is the ability to be customizable depending on your need. We have our standard DO4 that we've touched upon a little bit, but here we're going to cover the grid, a sample that's for MRI applications and another one for electrophysiology applications. We'll touch each one of these here in the next coming slides. So for MRI applications, some of the key benefits is that it's 50% smaller than cable coax solutions. So that, reducing the size in operating rooms is huge. So something that's very beneficial. 30% cost reduction, up to 100K mating cycles. Again, the temperature range from -40 to 125 C. Contact resistance less than 50 milliohms. And some of the performance, RF performance, is 1 dB of insertion loss, 20 dB of return loss, and a crosstalk of 35 dB for a two-way configuration, and a 50 dB crosstalk for a 4B configuration. Here we've shown some of the models that we've already implemented, prototyped, and now we'll get into some of the details for electrophysiology applications. So this one requires a lot higher voltage, meaning the main difference. The contacts here, the one that we've prototyped is 120 plus contacts. Termination size is 32 to 46 gauge. And one of the main benefits of this, or main characteristics of this, is the ability to go high voltage. We have high voltage pairs at 2000 volts and max current at 1 amp. Sterilization requirement was 40 autoclave cycles and 3 times ETO cycles. And the mechanical requirements for this application is greater than 7 pounds latch retention, 1,000 mating cycles, and 1,000 flex cycles. So flex being the cycles on the cable. Again, keeping the DO4 frame constant, and the contact technology is a combination of hyperboloid contacts and spring probes. The estimated annual usage for the plug is 10,000 cycles, and for the receptacle is 1,000 cycles.
And thank you, Daniel. So what we're going to show next is a short video. It's just over a minute long, so it's not terribly long, and it's just it's a video that you'll be able to find on our website as well, and it just introduces again the DO4 as a product line extension of the D series. It'll start by showing the connector itself, and it's now three product sizes. The DO1 ranges from 3 to 9 contacts. The DO2 can go up to 25 contacts, and now the DO4 goes up to 82, and those are all the standard configurations. Again, the nice thing about these contacts is we have, as Daniel mentioned, we have multiple contact technologies depending on the performance, the voltages, the mating cycles that are required, but also the harshness of the environment that the connector is going to be used in. Such as if it's going to be sterilized or aggressive cleaning chemicals. We can also integrate cable into these. We can mount cable and do the full value add assembly as well, which also helps our customers further streamline their supply chains. So the idea here is that we're trying to be a full value add partner and reduce both time and variation of projects that involve our interconnects. So to sort of start wrapping up, this slide here is intended to show just the breadth of what we cover. We talked mostly about high density solutions and in MRI imaging and in electrophysiology, but our medical portfolio is targeted at really treating a lot of key markets that rely on interconnects as a critical part of their performance. Everything from minimally invasive surgical and endoscopic applications like bone tumor ablation technologies, patient monitoring systems, even our individual probes are used in hearing aid type systems as well, or even in pill cam, if you're familiar with the endoscopic pill cams. Of course, we already spoke a bit about imaging systems. We focused on MRI, but really our interconnects serve markets in CT, PET, ultrasound, and X-ray as well. And then in the realm of disposables, we talked about limited use and also true disposables, such as electrophysiology, invasive probes, painless needles, and gas analyzers, and even more than that. So we do try to keep our portfolio targeted toward where we see the market heading, where we see trends going in the way of technology, but also in the way of accepted and reimbursable therapies, because we know that that's really what's going to drive the medical market forward in the way of improving patient outcomes. And then to wrap us up, so we talked a bit about the high density connector, its uses in the way of electrophysiology, and specifically in the mapping and ablation processes within that electrophysiology suite of therapies. We talked about imaging catheters, specifically ICE, but we also included IVUS in some of that conversation. And then the general imaging applications, again, where we see the need for really ruggedized, high use, high mating cycle connectors that can stand up to those electromagnetic fields without allowing interference. The key features and benefits of this new connector platform or a platform extension are the high density. Again, it's market leading density for the size. I think it's about, let's say, just under 1.25 inches from the diameter of the actual area where the contacts are sitting, where that insulator sits. And for 82 pins all the way up to 130 plus, as Daniel outlined, we could achieve. That is market leading density. The D-shaped layout and the testing and the one-hand mate and D-mate are all what we consider differentiators for this particular product line, because it is designed such that you don't need custom keying, you don't need to worry about how many pins you need, because if you need more than 130, you're probably not going to go with a probe type technology anyways, if you need more than 130 contacts. And then our testing is done to align with what we see in the market. So we do some autoclave testing, we do ETO testing, we also do voltage breakdown testing. All of these different types of tests that we've learned over the years are a lot of our customers need access to, and we have that readily available. Regarding the mating cycles, obviously we spoke a bit about cost per therapy, making sure that the connector is fit for use or fit for the environment that it's going to be used in. Whether it needs to be high mating cycles or it needs to be disposable, we can do either or. And then the enhanced functionality enabled by having such high connector density is another strong feature here. And I think now we are ready for a Q&A portion, Katie.
All right. Thank you so much, Justin and Daniel, for that great presentation and for sharing the video with us. So, gentlemen, our first question today: what is the maximum number of contacts you fit in the new D04 connector?
I'll take that question. Right now, we can fit on the D04, we can fit 130 plus contacts. Obviously, that depends on the type of contact we're using, but for spring probes, we can get very high density, and we can get into the 130 plus contacts for our D04.
And I can add a little bit. Thank you, Daniel. I can add a little bit to that as well. And the reason we say 130 plus is we do know from our experience that if you start getting too much higher than that on something like a pin design, we do know that from our experience, our customers start to have trouble with the return on investment of trying to train operators to actually assemble such high density cables and connectors. So when you're putting together a package like this, we do have to consider how easy is it to make, because that goes into the total cost to manufacture the device. So we are seeing a trend toward, what we're saying 130 plus, that we're starting to see that might be reaching almost the limit. I won't say it's the limit because there's always technology advances that could help solve some of those pains of trying to, put individual pins in these connectors and mount to them and put a cable on them and strain or relief it. We're always looking at ways to improve technology, but that is one of the limiting factors is, density only gets you so far when you have to rely on people with dexterity to actually manage putting these things together. So we are actually working on other technologies such as edge card type style technologies that allow for a little more room for termination of wires that will achieve even higher density and again, not the same size of a connector, but it's to help handle that next set of, let's say, requirements where the density is continuing to increase, but the traditional spring probe technology may not be the most favorable when you start getting too much higher than 130 pins.
All right, gentlemen, our next question. How is the 2 kV withstand voltage achieved? Is that with a custom insert to increase the air clearance between contacts?
Yeah, I'll take this one. So exactly that. It is with a custom insert that it's staggered axially between contact pairs. So one contact pair can be offset axially from the next contact pair, and that allows that creepage and clearance to increase, which is what gives us the ability to hit that 2,000 volt mark that we're achieving.
All right, thank you so much for that answer. So we've got time for 1 or 2 more questions. So gentlemen, I'm just going to grab this one from our queue. Why are higher voltage connectors being requested in the electrophysiology? Sorry for my pronunciation on that word.
That's all right. I can take that one. So in electrophysiology, what we're seeing is a lot of research being done and a lot of clinical studies being done in irreversible electroporation, which again, I would say that if there is a layman's term in medical for this, it would be pulsed field ablation, which is the delivery of non-thermal energy to ablate problematic tissue in the heart. The benefit of pulse field ablation or irreversible electroporation is that you're using electrical pulses that actually do discriminate tissue. And traditional thermal ablation, whether it's radio frequency using heat or cryoablation using cold energy, there is some risk to adjacent structures in the body. For instance, the esophagus is quite close to the heart, so when you're doing an ablation, you have to be careful not to put in so much energy that you're damaging structures that are outside of that tissue that you're trying to create those micro lesions to help return the heart to proper heartbeat levels. The benefit of irreversible electroporation is different tissues in the heart react to those electrical pulses in different ways. So you can actually create those ablations and those adjacent structures will not be impacted because they don't have the same electrical potential as the tissue in the heart. So you no longer have those risks, or let's say you have a much reduced risk of collateral damage, if you will, right? Or tissues that you don't intend to ablate are not going to be ablated. The trade-off is you have to use a pretty high level of voltage, at least when we talk about the amount of voltage needed to create a lesion in the heart. And we're seeing north of 1.8 kV sort of being the starting point, all the way up to, I think there's some that are being sampled that go up to 3 kV. So right now we've designed one that's at 2 kV because that's a current system we're working on. But that said, if higher voltages are required, we do have means to raise our voltage withstands even higher.
All right, so we've got a couple minutes left, so we're going to do one more question today. Why is the pin and socket technology an advantage over the spring probe technology?
Okay, I'll take this question. I would say that each option, each configuration has an advantages and disadvantages, right? I think one of the advantages for the pin and socket over the spring probe is definitely cost, right? Keeping that in mind, so that's one of the big advantages. They both have high mating cycles. The socket and pin is is a little bit better for carrying high currents. And the spring probes are better for board-to-board connection. So if you have that type of configuration, board-to-board, spring probes are definitely the way to go. So a lot of different things to consider, different details to consider. Those are just some high-level ones.
All right. Thank you so much for that last answer. So, gentlemen, we are out of time and we are going to start to wrap the webinar up at this time. So I wanted to say a huge thank you to Daniel and Justin for a great presentation and for answering some of our attendees' questions. So, gentlemen, thank you both so much for being here.
Thank you, Katie, and thank you, everyone.
Thank you all.
Again, thank you all for taking time to attend this webinar event. Take care, and we will speak with you soon.